Okay, so let me show you what I think is the most important trig identity. Sine squared of x plus cosine squared of x equals 1. Well, where did we come up with that? Well, it comes from the Pythagorean theorem. It kind of looks like it, but it's the Pythagorean theorem on the unit circle. That's kind of it in a nutshell. And so, let's see if I can get my good line here. Thought I had a line. I guess I don't. Oh well. Okay, so we're going to kind of pretend like this is the unit circle, and I don't know if I could draw a circle on here or not. Should have done that first. Okay. No, I guess I didn't do too bad. Okay. We'll just leave that. So that's kind of the unit circle, and if I were to draw like a theta in there, let's just say we'll make it like it's almost like a 60-degree angle, something. So that's my theta, my angle, and just going to drop down. So I'm making a triangle. So now we know that the length of this side, since this is the unit circle, everything, this is 1, meaning the length, the radius of this circle is 1 all the way around. This is 1 as well. I could put 1s, around every one. This would really be negative 1s if we were thinking about the coordinate system, but in fact, let me just erase those so nobody gets confused. We know that it's 1. Everything is just 1. So if this is 1, then this radius is also 1, and I'm going to write it in there. That's 1 as well. So where did we come up with this? Well, here's theta, and our value here, the length of this, well, that's just the y value, right, of whatever y this is. So this length here is just our y length, and then this length here, well, it's just our x length from this point to this point is our x, whatever x is, whatever x ends up being here, and this is our y. So if we were going to say, okay, so I'm going to try to get back, whoops, didn't mean that. Try to formulate this. This is what I want to end up with. So let me start by just saying, well, okay, if I wanted to say, what is the sine of theta? Well, the sine of theta is just, here's theta, and the sine of theta, well, that's just the y over the hypotenuse. So I'm just going to write that in. The sine of theta, that's my y over my hypotenuse. And so my y, we're just leaving as y. And my hypotenuse, we know, is always just 1 on a unit circle. So my sine of theta is really just y. Well, if sine of theta is y, if they're equal, we just showed it, then instead of y here, I could just put sine of theta for the length of this side, right? And now what if I wanted to know what's the cosine of theta? Well, the cosine of theta is just this x over the hypotenuse. It's adjacent over hypotenuse. So we don't know the value of x, but we know the hypotenuse is always 1. So that just reduces to 1. So now it's the same thing as up here. The cosine of theta is x. They're the same thing on a unit circle. So when we see an x, we can just type in cosine of theta instead. So now it's interesting. Now we can write this, because in a right triangle, and we know this is a right triangle, a squared plus b squared equals c squared. So let's just write it. A squared plus b squared equals c squared. Let me write it so it's all under there. So we'd have a squared plus b squared equals c squared. What's a? A is x, but x is really the cosine of theta. I could put the x's down. X squared plus y squared, put the x and the y down. X squared plus y squared equals 1 squared. But really, we could substitute our x's for cosine of theta. So cosine of theta squared we'll put it here, plus the y is really just sine of theta squared equals 1 squared. That stays the same. So there you have it. That's where we got that identity. Now 1 squared is just 1. So cosine squared of theta plus, I guess I don't have to rewrite this, but sine squared of theta equals 1. So we got what we intended on showing. Okay? So there you have it. Most important identity in my book. And remember, we can manipulate this identity. So sometimes they'll put the cosine squared of x on the other side, and you'll have, let me move this. Well, these are switched. They're the same thing, but they're just switched. But if we put the cosine squared of theta on the other side, then we end up with sine squared of theta equals 1 minus cosine squared of theta. So you might see this, and whenever you see this, you can substitute this in. Or if you had cosine squared of theta by itself and put sine of theta on the other side, you might see something like this. Cosine squared of theta equals 1 minus sine squared of theta. So then if you ever see this 1 minus sine squared of theta somewhere, you could be like, oh, I could substitute this in. So, these are the little hidden manipulatives of this identity. Okay? All right. Bye.